This video is part of a series of videos presenting solutions of problems related to the machine dynamics topic. This video presents the solution of a problem dealing with the determination of mobility of a mechanism involving gears. In this problem we are asked to determine the mobility of the mechanism shown here. First, recall that the mobility, m, of a mechanism is equal to 3 times L decreased by 1 minus twice J1 minus J2, where L is the number of links in the mechanism, L is the number of mechanical parts in the mechanism. J1 is the number of lower pairs, it is the number of kinematic pairs that allow, each, 1 degree of freedom. And J2 is the number of higher pairs, it is the number of kinematic pairs that allow 2 degrees of freedom, each pair. Here the mechanism is made of 7 links. The ground, the slider C, 3 bars, and 2 gears. Thus, L is equal to 7. The lower pairs here are the pin or rotating joints, and the prismatic or translating joints. There is one prismatic pair connecting the ground to the slider, as the slider can only translate vertically relatively to the ground. There is 7 pin kinematic pairs, all are simple and connecting 2 links each. Thus each pin joint is counted once. There is a pin joint between each gear and the ground. These are 2 rotating joints. There is 1 pin or rotating joint between the slider and the bar 5. There is 2 pin joints between the bars and the gear. Mainly, there is a rotating joint between bar 3 and gear 6 and there is a second joint between bar 4 and gear 7. Finally, there is 2 pin joints between bars, 1 rotating joint between bars 3 and 5, and 1 rotating joint between bars 4 and 5. In all we have 1 translating joint and 7 rotating joints. Thus, J1 is equal to 8. The higher pairs or the pairs allowing 2 degrees of freedom are cam joints or gear joints. Here we have 1 gear joint between the 2 gears. Thus J2 is equal to 1. Finally, the mobility is equal to 3 times 7 minus 1 minus 2 times 8 minus 1, which is equal to 1. Hence, the mobility here is equal to 1. The mechanism has 1 degree of freedom. Thus all links can be controlled by driving only 1 gear, for example. If the position of 1 link is known, for example a gear angle, the positions of all other links are predictable.